Well, welcome everyone. It's time to start our webinar, Quantity Takeoffs Made Easy. I'm happy to welcome you today for this session. I'll start with some practical announcements. This webinar is recorded and shared afterwards, so we have muted everyone. If you have any problems with sound or video stream, please let us know in the chat. And during the presentation, feel free to write down your questions in the Q&A section of this webinar. We'll try to answer as many questions as we can at the end of this webinar. Well, let's start with an introduction. Together with me today is Jacob de Sutter, my colleague. He is head of customer success. He is a civil engineer and he has 7 years of experience in software development. I'm Dieter Frooije. I joined Qonic last year, and before that, I worked 25 years as an engineer for a construction company. So I saw the evolution from making bill of quantities in a manual way with spreadsheets and 2D plans in what we did for the last 10 years, and that's a quantity takeoff based on BIM models. The agenda today is that we'll first talk about that link of BIM and quantity takeoff. Then we'll have a live demo done by Jacob, and we'll end with the Q&A section. I'll start with the quote, "Quantities are a quick win." Of course, you can do a BIM project without quantities derived from the BIM model, but when you take time to invest a little bit more time so that your BIM model is useful for quantity takeoff, then you'll gain a lot of time afterwards for yourself and for all the team members. And your quantity takeoff will be less error prone. There is a but. You can encounter some hurdles before you have a useful and correct quantity takeoff. Well, let's dive into that more in detail. What is a common practice today? On the one side, we have the modeling tools, the authoring tools to create a BIM model. They're mainly used by BIM modelers, and it's possible to read out some quantities within that software tool. You can create a schedule with the quantities or export them as a schedule useful in spreadsheets. It's also possible to export the files as an IFC file containing those base quantities. And on the other hand, you have IFC-based software, and there are many types. You can have viewers, you have software used for coordination, and they almost all let you do a quantity takeoff. We see that with this setting, there are some pain points. First of all, the modeling itself and the quantity takeoff are separated worlds. The modeling is mostly done by a modeler. A quantity takeoff can, for example, be done by a quantity surveyor. They all use their different tools, even different software applications, and they have their own responsibilities. But you can see that there is a problem. What if the model is changed by the modeler? And what if the quantity surveyor wants to correct some data? That difference is not synchronized all the time. Linked to that, you can have a limited usability of BIM models. Quantity takeoff is only one of the many workflows you have in a BIM process on a BIM project. And so not all the time the BIM model is suited for a reliable quantity takeoff. You can, for example, see that the geometry is overlapping, that there is not enough detail in the BIM model, or that data is missing or of bad quality. So that this limits the usability of a quantity takeoff. Then we can say that there is a limited toolset available in the software applications. You can almost always count elements, calculate the length, the area, and the volume, but in our industry, we need a lot more than that. For example, what if you want to count the number of the number of steps of a stair, or if you want to calculate the length of a handrail? What if you want to calculate the weight of an element, or the area of formwork? And you have also different measurement rules. So if you want to calculate a gross or a net area, then you want to set a threshold for the openings. We can also say that authoring tools and the software applications used for quantity takeoff are not flawless. It can happen that one of the measurements are not correct. And it can be very time consuming to check and compare these values to determine which ones are correct. And rarely you don't have visual feedback in your software to see what quantities are calculated. And so what's our solution? In the first place, and that's under the hood, that all elements in the BIM model are solids. So this means that when we calculate the quantities, that they are correct and reliable. A very valuable point is that we support a complete workflow. It starts with importing BIM data like from Revit or IFC files. Then you can add data, you can correct data and correct geometry. You can derive the quantities as a quantity takeoff and reorganize them. You can share them with your team members or export the values if you want so. If there is time pressure, like for a tender phase, it's also very helpful that we have a multi-user environment. You can work together with your team members at the same time and synchronize your work all the time, so you work always with the latest version of the data. End to end, and as you can see in the image on the right side, that we have a good visual feedback of the quantities that are calculated and which elements are related to that calculation. So I'll end with the quote I started, that there is a quick win doing a quantity takeoff in a BIM project, and Jacob will show now how that works in Qonic. Thank you.
All right, thanks, Dieter. Let me show these points that you outlined during this introduction in the product in Qonic. So can you see my screen, Dieter?
Yes, I do.
Okay, great. Let me just... All right. So I've opened a model here where I already have a sort of quantity takeoff, a simple flat list of all the materials in this model with their quantities, their measurements, so you can decide for each material, in this case, what kind of measurement you want to show, with always the visual feedback. If I want to know, for example, this plaster, what is this plaster actually in the model? I can quickly give this a color override so I can clearly see what is going on. So all of these plaster layers are now highlighted in yellow here, which makes it very visual and easy to see what a certain row in this list is about. Now, how do I get to this kind of quantity takeoff? Let me actually go back to the beginning where I have a project open in Qonic. So when you start Qonic, when you sign up for your first account in Qonic, you'll be greeted by this sample model, which you can use and explore, or you can just create your a new project, and in this new project, upload your own models. So Qonic supports IFC files, also Rhino and Revit models can be imported directly into Qonic, and from there you can get started on creating your quantity takeoff. So let me open this model here. It's the sample model in Qonic, and create some quantity takeoffs from this model. Before I start, actually, let me just limit my scope, so I'll quickly isolate this one wall, so I can very clearly show you how these reports or these quantity takeoffs work. So to create a report, all you have to do is click the report button on the left-hand side here. And you will start with a report of your model based on some grouping and filtering rules. So in this case, the only grouping rule I have enabled is group by material. And it shows me in this case there's only one material available in this model, which is the exterior wall sand lime brick. Now, actually, I know in this model that this exterior wall actually consists of 4 separate materials. So I can see here this exterior wall indeed consists of 4 layers. These 4 layers are defined in the originally IFC file with each their layer and the thickness, a separate thickness. But these layers were not explicitly defined as geometry inside the IFC file. So I cannot interact with them directly. I cannot get the accurate quantities per layer out of them because they were not defined explicitly. Actually, I can use Qonic to define that explicitly. So I can choose to split this wall into their layers, which now you can see are separately defined as 4 separate layers, each with their own thickness, material, and now 4 different quantities in my quantity takeoff here. So I can say, okay, maybe for the facing bricks here, I want to know the net area. Maybe for the insulation, I want to know the gross area, just saying something. Maybe the net volume for the sand lime bricks. So you can per row define which kind of measurement you want to see. And you can always get visual feedback about how something is calculated. So for example, the net area of facing brick, I can get this quantity preview, which shows me the outline of how this area was exactly calculated. So in this case, it's along the center of this brick layer, cutting out the openings for the windows. But for example, the gross area for the insulation will not cut out these openings because we're calculating the gross area here, of course. So you always have visual feedback about how something is calculated. Now you can use Qonic to continue working with this model and actually upscale it. So for example, let's say I want to add some more detail in this model. I want to create a lintel above this window. We can use some very generic tools like the box tool to create some new geometry. Let me use push-pull to make sure this lintel extends to where it needs to extend. All right. And now we've basically added this lintel, which currently is just a generic box. I'll give it a name. I will assign it to its correct location in the building. I will assign it the correct IFC class, and also I will give it a material. So let's say this is a precast lintel, like this. And now finally, let's also subtract this volume from the original wall. Voila. So now we have this lintel modeled in our wall above the window, and we'll see if I now check my report panel, I will also have this reinforced concrete precast as a new row in our takeoff. In this case, it shows me the net volume. Again, I can get a preview of how this quantity is calculated, just like this. And now also my net volume for the sand lime brick is also updated because we subtracted the volume. It's now also going to take into account the subtracted lintel. So this takeoff always stays up to date with what you're doing in the model. Even let's say I get rid of this window, you'll see my volume here update again. Let's say I want to copy this window with the lintel, like this. It always remains up to date. So you always have this very visual feedback of what you're looking at, and you always have the correct quantities out of your model, which is, of course, very useful. Now, let me take a look at the 7th floor. So I'll just quickly isolate this floor, and I'm going to do the same thing that I did with this wall. So I split this wall into their layers. I'll do the same for all the walls on this floor. So I'll just select all the walls, split them into their layers. I can still interact if, for example, some of the walls, the order of the layers was incorrect during import or incorrectly defined in the IFC file. I can still flip around where necessary. And then, of course, if you want to get accurate quantities, we'll need to make sure that all of the materials are accurately modeled as well. So, for example, the connections between walls, we'll need to make sure that these material layers also correctly connect like they would in real life. So we do have some tools to resolve those kinds of issues. We can manually connect, let's say, these two walls like this. Or I can choose to take all of the walls on this floor and connect them all together. So this to make sure that all of the material connections are correctly set up, which will in turn make sure that our quantity takeoff, again, is much more accurate and much more correct. So it will locally try to resolve all of these connections. If at some point a connection has failed because our algorithm didn't know how to do it, you can still intervene manually like this. So you'll always have the correct connections. Now let me quickly hide the furniture for a minute so we can take a closer look at adding some more detail to our models. For example, in this design model where I've already have some materials defined, there's, for example, no finishing layers defined yet. Maybe I want to add some plaster layers or some tiles to some of my walls. That's also possible in Qonic, so I can just say, okay, I want to add a layer. Let's choose a material. So this material library is, you can either import your own material libraries, you can define them for an entire project, so you can use the same materials across your different models in a project. So you always have the correct, the single source of truth in terms of materials. So let's use this plasterboard with a thickness of 15 mil, and I'll just click where I want to add this layer. So it added this to this one wall, or I can choose to apply it to the entire room, which will basically redo the entire thing across all of the walls in this room. So now we can see we have this plaster layer neatly added along the corners here. Also in front of the lintels that we just modeled. And I can continue, for example, maybe I want to add in this room a plaster layer. Again, I can just continue clicking. It's all pretty intuitive. All right, and once we're happy with that, again, we can check out our quantity takeoff and make sure that, for example, these plaster layers, where are they? The net area for all these plaster layers are just added is around 140 square meters. So you always have this very, this live feedback of how much material you're adding. Now, the fact that we use this wall, so we split up this wall into its layers, and we've added a layer of plaster here in this room, but for example, not in this room. It allows for a very flexible way of adding these materials and defining your wall layers. So you're not restricted to a list of materials that is in a special order. We can actually have different kinds of combinations of materials in all kinds of different geometric compositions. For example, let's say I actually want to define some tiles up to a certain height in this room. I can say, let's slice this plaster layer up until a height of 1200 mil. Get rid of this lower part and actually add some tiles here. Some ceramic tiles, again with a certain thickness. I'll just click where I want it. And now you'll see if I isolate this wall here, that we have a combination of a wall without finishing and then a wall where there's plaster and tiles at the bottom. So again, very flexible. We always have this visual feedback of how a certain quantity is calculated. So for example, the tiles net area would be calculated like this, the plaster like this, and so on. Or we can do some very quick point measures. With our laser tool, we can just click, okay, what's the height and the width of this layer? Again, just very intuitive and very quick to get an idea of the dimensions of this model. All right, so once you've basically, once you've set up your model and you've added the details that you need for correct quantity takeoff, you can actually, let me switch to another model here. You can get your entire list of materials out of it. So this is the same model, but I've already added all of the plaster layers and details to the model so that we have our correct quantity takeoff. Again, we can set up our report by defining certain grouping or filter rules. In this case, I just have a flat list of materials. So again, I can choose to colorize, for example, the plaster layer so I can quickly see where are those plaster layers located and how are they calculated. You can do this for all kinds of data in your report. So for example, maybe I want to know, okay, different kinds of concrete. Let me actually visualize them where they are. So now I know, okay, all of the yellow geometry here is this precast concrete, all of the red is the reinforced concrete, and so on. So there's always very visual feedback on how you calculate something. You can choose for each row what you want to calculate, so net area, gross area, net volume, and so on. This list of measurement definitions will be extended in the future, so you can very granularly customize how you want to measure something. And once you're happy with your list, of course, you can export this report to an actual report on the project dashboard. So, for example, in this case, I'll call this the material list for this model or for this project. This will now save or create a report in the project dashboard, which can then be shared with other people in the project. Let me give another example of a report. So this was just very simple materials and their quantities, but you can basically add any kind of setup in terms of groups and filters. So for example, let's say I'm interested in the doors and windows. So I'll just filter on only IFC class door and window. And maybe I want to group them by, let's say, by fire rating. So any property that's in the model can be used as a grouping or filtering rule. So let's say I want to group by fire rating, and I'll just create a list from that. So now I know I have 215 doors with F60 fire rating and 50 doors with F90. Again, you can colorize them so I can see where they are in the model. I can continue working on this list. So in this case, it's a very simple doors and windows by fire rating, but I can add more grouping rules. For example, maybe I also want to group them by height. So you get a more detailed list of them split up by height as well. Maybe I want to add some more properties as columns in this list. So maybe I want to show the manufacturer, or maybe the width or the acoustic rating. All these properties can be added as a column in your list. So you can get a very generic list of any kind of objects in your IFC or Revit model. Again, once you're happy, you can create a report of it, which will then be saved in your project dashboard. It's also possible to assign or to use classification systems within Qonic. So in this project, actually, I already have defined or I have imported a classification system. In this case, it's NRM. And I have defined or assigned classification codes to objects in my model. So if I open my codes library here, I have this NRM library where I can see that certain objects have been assigned a code. So all of these codes, they're just taken from the Building Smart Data Dictionary. So we import libraries from existing systems, so we don't have to define them ourselves. If you want to define them yourself, you can, of course. but it's always good to use a standardized system. Now, let's say, for example, there's this code for external doors, and I can see already assigned 4 elements to this code, or assigned this code to 4 elements, or the internal walls, for instance. So once you set up your code system and assigned codes to your objects, you can again, of course, use that to create a report. So I will just edit the structure, get rid of these groups and filters, and I'll just group by code. So it gives me an entire report based on the code that's in the codes that are in my model. It's calculating all the quantities. And of course, it uses the tree structure that's defined in the classification system, right? So you can reuse the same system over your different projects. Okay, so for example, if I take a look at the beams here, net volume can be calculated. Now, the great thing about these existing systems, classification systems, most of them come with predefined assignment of measurement definitions per code. So for example, in NRM, it's defined that the beams with this code should be calculated in net volume, or maybe let's say the stairs should be in count, roof should be in net area, for instance. These measurement definitions are defined in the system. They're imported in Qonic, so you don't have to modify it or customize this. You can just use it as is and get basically a standardized quantity takeoff from your model. So again, I'll just export this report, QTO according to NRM standard. I'll save this. And now if I go back to my project dashboard, I will see these 3 reports I created during this demo available in my project. So the material list that I made earlier, it's basically the same information that's displayed here as before, except now it's in a list format in the project dashboard, again with the measurements that we chose. Same goes for the doors and windows list, and also this NRM quantity takeoff. So this can be shared with people across the project. If a certain stakeholder wants to know, okay, what is this net area of external walls actually? I want to see this in the model. You can really easily click this link here, which will open the model with those objects selected. So you can always really quickly go back to the model, see what a certain quantity is about. Like this, for instance. Okay, I have one more example of a MEP model here, where I have already prepared a little quantity takeoff based on the system types and the IFC classes within those systems. So again, whether your model comes from IFC, Revit, or Rhino, whether it's an MEP model or architecture structure, you can use all the information that's in the model and get lists out of them really quickly. So in this case, it's a very simple structure grouped by the property system type and grouped by IFC class, which gives me this list. I can choose to, let's say, colorize a certain system so I can quickly see what it's about. So this domestic cold water system is visualized here with the pipe segments in orange, the pipe fittings in yellow, and the valves in green. And again, we can get quantities out of them. So the length of all the pipe segments in this system is 19 feet. If I want to know how it's calculated, I can get this preview, which will show me basically where it takes that measurement from. So in this case, the axis of those pipes, of those pipe segments. Okay, I think that's pretty much all I wanted to show in terms of quantity takeoffs today. There's obviously a lot more in Qonic that we haven't shown today, but this already gives you a good idea of what is possible currently in the product, and yeah, how to get started with quantity takeoffs in Qonic. Okay, Dieter, I think you can share your screen again.
Thank you very much for your presentation. I see that we have some nice questions and we'll go one by one through them. So let's go.